This is the data set that we were looking at in one of the other videos. It's just a data set with some made up data values. And I showed you how to calculate all of these values with these 3 columns of data. And I didn't explain the values for skewness and kurtosis, meaning I didn't show you how to calculate those values by hand, because I just wanted you to understand the idea behind what those values are showing. The same thing is true for correlation coefficient, meaning I'm not going to show you how to calculate a correlation coefficient by hand, but I just want you to understand the idea behind a correlation coefficient. There is a formula that can be used to calculate it by hand, but we won't use that formula in this class. Just like how we aren't using the formulas that would be used to calculate skewness and kurtosis by hand. Each of these values, all the way up to kurtosis, are calculated with 1 column of data, meaning when Excel calculated these values for the age column, it took these 5 numbers in the age column and plugged them into different formulas to calculate all of these values, all the way down to kurtosis. When you calculate a correlation coefficient, you're actually plugging 2 columns of data into a formula. So we could ask Excel to calculate the correlation coefficient for age and number of units, and it would plug in all 10 numbers into a certain formula to give us the correlation coefficient for age and number of units. So let's do that. To get the correlation coefficient, we type in equals CORREL, we put a parentheses, and it says array 1 and array 2. We can highlight age for array 1, then we need to put a comma, then we can highlight number of units for array 2, and then close the parentheses, press enter. It gives us a correlation coefficient of positive 0.47, and that's a positive number, which means that in this data set we have a positive correlation between these 2 variables. Let's make a scatter plot to show that it actually is a positive correlation. We can highlight these numbers and then go up to insert. You can't see what I'm doing, but I'm going to create a scatter plot. So it is somewhat of a positive correlation, because right here we can see that the dots are rising from left to right. This dot over here is more of an exception to the pattern. We can also create the correlation coefficient for age and number of children. So let's calculate that correlation coefficient. I'll put the one for age and number of children in here. So equals CORREL. Highlight this column, put a comma, and highlight this column, and it'll plug these 10 numbers into the correlation coefficient formula. We get negative 0.36, which means in this data set we have a negative correlation between these 2 variables of age and number of children. Let's make a scatter plot to see if it looks like a negative correlation. So it's really hard to see any pattern, but the value is saying that this is a negative correlation. I guess it's because maybe here you can see maybe these dots are dropping from left to right. It's probably a fairly weak negative correlation, which means it's very difficult to actually see that it's a negative correlation. What about we could do a correlation coefficient between number of units and number of children. for this last pair of variables. And it comes out to 0.20. So it comes out to a positive number, so there's a positive correlation between age and number of children in this data set. Let's go back to this slide right here. And I'm going to mark off where these values came out to. First I need to finish this number line. Let's mark off these correlation coefficients. The correlation coefficient for age and number of units came out to 0.47, which is right here. Or it's about right there. The correlation coefficient for age and number of children was negative 0.36, which is about right here. And the correlation coefficient for number of units and number of children was 0.20, which is about right here. 0.2 is the same thing as 0.20. So let's focus on these two positive correlations for a second. One of them was for age and number of units, and one was for age and number of children. No, I'm sorry. This one was for age and units. This one was for units and children. Let me check that again. So the correlation between age and units was a stronger positive correlation than the correlation between units and children, because this correlation came out closer to 1, and this one came out closer to 0. The one that comes out closer to positive 1 is stronger. Now let's look at what the negative correlation came out to. It came out to negative 0.36. Let's compare these two correlation coefficients. And let's think about which one is stronger. Actually, the one that's further from 0 is stronger, so this one is actually stronger than this one over here. The negative 0.36 is actually a stronger correlation than the positive 0.20 because the strength is just how far it is from zero. So if you want to know which one is stronger, just ignore the negative sign and then just look at which one is a bigger number, and that'll tell you which one is stronger. So for example, negative 0.70 or negative 0.7 would be stronger than positive 0.3 because negative 0.7 is further from zero and positive 0.3 is closer to zero. So my main point is if you have a negative correlation and a positive correlation, it doesn't mean that the negative correlation has to be weaker than the positive correlation. So negative doesn't mean the same thing as weak. A lot of people might tend to think that a negative correlation means weak and a positive correlation means strong, but that's not true. The strength is actually the distance from zero. And there's actually some guidelines for what's considered weak and what's considered strong. I'll put these guidelines on the screen. These are just rough guidelines. Anything between 0 and 0.4 would be a weak positive. Anything between 0.4 and 0.7 would be a medium positive. And anything between 0.7 and 1 would be a strong positive. Anything between 0 and negative 0.4 would be a weak negative. Anything between negative 0.4 and negative 0.7 would be a medium negative. Anything between negative 0.7 and negative 1 would be a strong negative. So notice how these numbers over here match up with these numbers over here. So at the positive end of the number line, between 0.4 and 0.7 is a medium positive, and at the negative end of the number line, between negative 0.4 and negative 0.7 is a medium negative. And we can see that as we go further from 0 up here, we're moving up from a weak positive to a medium positive to a strong positive as we get closer to +1. In this direction, we're moving from a weak negative to a medium negative to a strong negative as we're getting closer to -1. And -1 is a perfect negative, which means a negative correlation can't be any stronger than -1. And +1 is a perfect positive, which means a positive correlation can't be any stronger than +1. So it's actually not possible to get a correlation coefficient beyond -1 out here or beyond +1 out here.